Hi, welcome to this month's version of the FDTD Goes Applications webinar. This month, we're very pleased to have John Stopkati, the Sioux from North Platte, Nebraska, talking about the use of low-level water vapor in diagnosing the EML, the elevated mixed layer. John, if you can advance to the next slide. We'll just go through the protocol. This is part of a series. Dan Bikos and I are always, I'm Scott Lindstrom. Dan Bikos and I are always looking for speakers. So if you have a topic if you have something to speak on the topic of using GOES satellite imagery or VIIRS JPSS imagery in the forecast process, let us know and we'll help guide you into a talk here. Next slide, please. We'll have about a 20-minute talk here. You can send questions via GoToChat or you can ask them at the end. Please don't press hold. Mute if you're not speaking. Thank you. Take it away, John.
All right. Thanks very much for allowing me the chance to kind of go through this case. Thanks, Dan and Scott and all the folks at Zero and Sims and FDTD. This is just a little case that kind of came upon me shortly after the whole mandatory telework thing. So started telework on the 17th of March. I did anyway, and then this little system came through a couple days later. So I was still at home trying to figure out ways to capture and archive data that I couldn't normally get to when I was at work. So So I was able to just kind of screenshot a lot of these images and with some help from the folks at Sarah and Sims, kind of filling in the gaps here and there. So this particular day, again, March 19th of this year, you can see by the highlights map here, the headlines, we had blizzard warnings in the Panhandle of Nebraska. We had a winter storm watch across our Sandhills region. And then winter weather advisories for the most part further east, and you can see a lot of winter weather highlights here across the Rockies and the west. Meanwhile, the severe potential was there as well. So you can see the day one outlook there for an enhanced risk across eastern Nebraska, southeast Nebraska, which included a 10% tour outlook, along with some hail and wind, hatch hail outlook area there. So for my CWA, we were expecting a few thunderstorms in the very southern part of our CWA, but our big concern was the blizzard conditions in our northwest, the part of the Panhandle that was our counties as well, and then of course, the CWAs to the east were expecting severe weather, including that 10% tour threat. So, again, I just captured a few of these images along the way as the event was happening. They don't really have a typical 500 millibar map or anything like that. So, just a quick look at the sounding from North Platte that morning. It's pretty moist in the low levels there. There's a little bit of cape aloft, but you would have to go way up to be able to realize that cape. But the interesting thing was that we had mid-40s dew point on the sounding, that morning, which was relatively warm for that time of year. Again, some cape noted, but well above the surface. So a quick snapshot at 1616 UTC in the low-level water vapor. The things that kind of jump out to you are the brighter, colder colors, of course, across Minnesota and Iowa. But across our area, a pretty thin area from north central Nebraska into the Panhandle there, where good mid-level F-gen signature, which at that time in the morning was producing primarily a cold rain, and then it switched over to snow later on. But there was good moisture in the boundary layer north of the front. But you can see there by mid-morning here that across western Kansas, the low-level water vapor was showing something significantly different. So this EML was developing across western Kansas at this time, as noted by the black circle there, the darker red colors on the GOES 16 image. So just also glancing at the Dodge City sounding from that morning, we didn't really capture the EML at that particular time. The little snapshot of the low-level water vapor in the bottom left corner of the screen there can kind of give you a hint, although it's hard to see the states on that. But simply, the EML was off to the southwest of the Dodge City area at this time the sounding was taken, so it wasn't captured really well. There are hints of it in there, but for the most part, still low or really good moist low levels in the sounding at 12Z. However, by 0Z, you can see a much different looking sounding, and we'll kind of step through as this progresses along the way. But you can see kind of nearly an inverted V profile remaining, with dew points dropping into the mid-20s by 0Z that evening in the Dodge City area, and then the Sampson around 70. So jumping ahead about an hour here to 1716 UTC. Again, mostly in our area, we were looking at the mid-level FGen signature producing mostly snow by this time, still a little bit of cold rain. But it had intensified from the previous hour, and that was kind of our main focus of what we were looking at. Winds were starting to increase at this time. And we were starting to see visibilities drop across the western sandhills into north central Nebraska. Meanwhile, the EML was starting its progression across western Kansas there. Again, the black circle kind of showing that really dry low levels there. So here is just a basic snapshot, WPC frontal position around 1 p.m. that particular day. You can see the front was well through our area here in western and north central Nebraska. But you can see, evidence of the remaining stationary front in southeast Nebraska, hence the reason for the TOR outlook and the more severe weather outlook in the warm sector there and along the warm front. There again, the western and north central part of Nebraska, which is our area, was well behind the front by that time. So jumping ahead another hour at 1816 UTC, we're starting to see a couple of convective elements in there. But again, our attention primarily focused on that mid-level FGen signature, producing some pretty good snows at this time. And by early afternoon, that mid-level FGen signature expanded across our area, as you can see there, fills in quite a bit more area than what we had originally seen early in the morning. But those two yellow circles that you see on the screen there kind of mark the convective initiation that's occurring just along the front, but also back into east central Colorado. This is occurring on the northern fringe of the EML as it was progressing eastward. But also notice in far southwest Nebraska, I don't know if you can see my mouse here at all, but where the red colors are in far southwest Nebraska, looks like low-level moisture, at least the interpretation of that would be that at least you're seeing further down into the atmosphere and possibly a drier signature indicated there. I will say at this time, the Imperial, which is down in the far southwest corner of Nebraska, was in the mid-40s, low to mid-40s, overcast and seeing drizzle at this time, with dew points also in the low to mid-40s. So very moist, very low levels at that time as well. So at this same time, I've also captured the 0 to 3 kilometer lapse rates from the the SPC mesoanalysis page. So I like to look at these quite a lot because they can tell you a lot of different things. Boundary locations, areas where, maybe that convective initiation is going to start, along with other things, of course. But the low-level lapse rates tend to tell you a lot when you're looking for surface-based convection. So you can see that the lapse rates were steepening across eastern Colorado into western Kansas there, which kind of goes along with that low-level satellite picture there from GOES 16. Cold air was well to the north of this, of course, although we'll see over time that this lapse rate gradient across southern Nebraska, the gradient itself was starting to increase as the colder air was also moving south. So we're starting to see maybe some hints that low-level forcing will be a little bit more evident. And then in the satellite picture in the upper left here, I have a little dashed yellow line that kind of indicates where that convective initiation might be starting out on the northern and western fringe of the EML. We'll go ahead another hour here to 1916 UTC, and you can see the mid-level F10 signature still looks pretty good across western and north central Nebraska. Some kind of brighter blue colors showing up here, maybe even showing a little bit of convective elements on the very southern fringe of some of where that snow was falling. But by this time, we were starting to see snow rates of 1 inch per hour, maybe a little bit greater, visibilities less than a mile, in some cases maybe around a half mile or so. So really starting to see the effects as the winds picked up as well, over 40 miles per hour, I believe, around this time. So, those blizzard warnings were looking pretty good out in the Panhandle, and certainly the snow was coming down pretty good there. Meanwhile, the EML is continuing to progress across Kansas there, now located primarily across central Kansas, as it's, kind of mixing out further east. But you can see that on the northern and western fringe of that EML, we're starting to get much more broad, I guess, convective initiation happening there. But again, still on the northern fringe of that, kind of where we saw those lapse rate gradients a little bit ago, and we'll look at those again here in a second. But also note that there's some convective elements now in southeast Nebraska that probably are elevated, at least to start with. But again, these central back into northwestern Kansas, probably a little bit closer to surface-based convection there. So again, here's a look at the SPC 0 to 3 kilometer lapse rates from 19Z. And you can see that gradient is really tightening in that same area where convective initiation has started, going from, I guess, eastern Colorado through northwest Kansas into south central Nebraska. So we're kind of starting to get worried in our area, not so much for severe maybe, but, from a DSS perspective, are we going to start needing to think about lightning and those kinds of things to start let folks know about any kind of lightning signatures or something like that. So at the same time, again, looking at some other features from the SPC mesoanalysis at 19Z, the deep layer moisture flux convergence picking up across south central Nebraska, and you can see the mean mixing ratio, getting wrapped, I guess, on the north side of the upper low there into southwest Nebraska. So again, that's kind of aligned right along that low-level lapse rate gradient, and so in that region of convective initiation. Jumping ahead one more hour here to 2016 UTC. Convection continues to increase across the area. those yellow circles there indicated, showing how the convection's kind of picked up, and again, maybe some elevated stuff in eastern Nebraska there, but certainly this stuff back towards south central Nebraska looks pretty good, pretty intense there. I will say that temperatures in this area at this time were, I believe, in the 40s to 50s, but here in far southeast Nebraska, we were still seeing temperatures in the 70s at this time. So on the south end of that front, still some pretty good low-level moisture and, temperatures in the 70s. But we can see that the EML has progressed across Kansas even further. That convection initiation continues to occur on the north and west side of the EML, which is kind of wrapped westward there thanks to the low positioning near the Colorado-Kansas border. So for our area and our southernmost counties here in southwest Nebraska, Hayes and Frontier counties, that's where we were starting to get a little bit concerned about, just how much convection are we going to see with likely pretty low melting levels, or freezing levels, I should say. Are we going to start to see some hail concerns? And again, is lightning going to be a DSS concern for us across this area? Again, a look at the low-level lapse rates. Again, you can see in western Kansas here, based on the mesoanalysis page anyway, these 10 degrees C per kilometer lapse rates have kind of gone northward here now towards the Nebraska border, increasing that gradient, very tight gradient there in that area. So again, starting to see some higher instability, along that front, resulting in that increased convection. But as you see, the convection, it didn't initiate along the entire boundary there, but rather in pockets there that, so it wasn't widespread right from the start. Low-level moisture was also, or convergence was also increasing right across the Nebraska-Kansas border there. So again, starting to give you some confidence in kind of what layers that convection was starting to initiate there, pretty close to the surface. Even though back in northwest Kansas, we're still looking at pretty cold temperatures. So some of this stuff further west might be lost a little bit. And then just checking out the surface-based CAPE, again, as you would expect, south of the front. Pretty decent 0 to 3 kilometer CAPE in this region, which is another thing that I like to look at. Kind of give you a little bit of confidence in surface-based convection. At the same time, you'll see that the SIN values across central Nebraska are increasing. Again, that very tight lapse rate gradient there. So starting to really show that warm sector south of the front and across eastern Kansas as well. So one more hour ahead, 2116 UTC, still getting some pretty good snows in the sand hills in north central Nebraska. Convection increasing across south central Nebraska. Now, a lot of these convective elements were moving north or northeast pretty rapidly. So you kind of had to wonder, even though it may have started close to surface base, it probably became elevated pretty quickly. And in our area, with the SIN values increasing pretty dramatically in the very cold air north of the front, we could start to now see some confidence in the fact that, even though these things may produce a collapse of thunder or something, severe prospects in our area were probably not going to be that big a deal, although we were still continuing to monitor for the large hail potential there. And there again, there's that really tight lapse rate gradient supporting that surface-based partial acceleration, from the LFC, or to the LFC, I should say. So that gradient extends, pretty far to the northeast there in southeast Nebraska. So that's, obviously where there's a lot of concern for more widespread severe weather. And then there's that low-level cape. Again, those thin values kind of indicating the colder air was indeed pushing south pretty rapidly at this point. So our confidence in not getting severe was increasing at that time. To throw in, just for fun there, the low-level 2D frontogenesis, as you would expect with that lapse rate gradient there and everything coming together, pretty good frontogenesis occurring in the low levels right there. So just a few take-home points. Again, looking at the low-level water vapor imagery, pretty beneficial in tracking the EML in this case. Probably should have included a weighting function graphic in there, but again, the EML usually resides above the low-level moist layer, which, pretty instrumental in capping the environment to begin with, but it also can serve to limit convective development in space so that, you're really getting the best initiation where those more rigorous partial accelerations are happening there. So when you get CAPE available to only a few storms, tends to make them a little bit more intense for those that can realize that CAPE. When you pair the low-level water vapor imagery with the SPC mesoanalysis graphics, it can really help to focus your attention to where convective initiation will occur, and then to what degree as well. And of course, whenever your offices are trying to incorporate mesoanalysis forecasters more and more, which is a great thing, trying to use all these different tools and make them available in the toolbox to help really kind of hone in on where the DSS needs to occur. And that's all I got.
Okay, thanks, John. We have time for some questions. If anyone would, I haven't looked to see if there are any in the go-to. Dan or Brian, if you could do that. But does anyone have a question? Just break in, unmute yourself, and ask the question to John. Otherwise, I have a question, but I'll wait. Okay, I will ask my question then. I was really struck by how you had the cold cloud tops in the frontogenesis, and then you have next to that, or just south of that, the elevated mix layer. And I'm just thinking of a three-dimensional up in the frontogenesis and coming down in the elevated mix layer. So I'm kind of curious, not being too familiar with Nebraska climatology and the water vapor imagery, how common is it to have this kind of situation where you have the elevated mix layer sweeping across Kansas at the same time you have the very strong frontogenetic forcing over Nebraska? Is that something you see fairly frequently?
I think in the, although I don't have, just anecdotally, I think it is, I wouldn't say common, but I think when you get these more dynamic systems moving across the mid-latitude, certainly the opportunity to see that exists. It's not out of the question for our area to have severe watches and winter watches at the same time. In fact, I've been around long enough to have seen a tornado warning and a blizzard warning in the same county, Cherry County. Of course, Cherry County is the size of New Hampshire or something, or Delaware. But point being that we do get these pretty drastic air mass separations, I'll say. I guess the part that really struck me, not only the EML and the way it looked on the low-level water vapor, but after pairing it with the SPC mesographics and that lapse rate gradient, that has to tell you something about the, not only the fact that you're dealing with different air masses there, but the degree which they are all, pretty extreme. So, kind of long-winded answer, but I wouldn't say common, but certainly you probably see a couple of these, I would think at least, per spring season. But the one thing this has done is opened my eyes to trying to capture more of this kind of thing.
Okay, thanks. And I will also ask, were you looking at GLM data on this day?
I did not. And the only reason being, as lame as it sounds, is I didn't have a good bookmark at home at that point. It was right there on some of the other things that I was looking at, but I was so kind of dialed into the EML aspect that I didn't even get to that part. I think I did later when stuff was really taking off in southeast Nebraska, but for us, I didn't. However, I have since then, and have found it pretty useful, especially with, in fact, we had a case, I think it was about a week ago or maybe a little more so, where we had some pretty shallow convection when things were pretty ripe and ready to go. But the GLM data to me was pretty telling in that it was not, things were not really taking off like they should have been. And so it was kind of telling by just watching the energy area there, that it wasn't increasing. So I think there's still a lot to be gained there for me in trying to see where this fits in those kind of hybrid spring-winter seasons.
Okay, thanks. Does anyone else have any questions?
As a side note, we did end up with, I think, a pretty decent area of 6 to 8 inches of snow across the sand hills. And I think maybe we had one report of 8 to 10 maybe thrown in there. So we did, down here in North Platte, we did switch over to snow at some point, but we didn't get as much as further north. But certainly where that mid-level F-Gen band was pretty apparent, they did get some pretty good snow.
Okay, well, that's a wrap. Thank you very much, John, for your talk.